Hi guys, welcome back to today's lesson on ETABS. In today's lesson, we are going to be designing the slab. So there are two ways of designing slab in ETABS. First is using the finite elements method, then the second is using the strip method. Okay, so before that, let's check the moments on our slab. So come here, you can see this display shear stresses and forces. So you select this and you choose the combo you want. Okay, so the combo, for example, for my slab, I want to use Udicon 2, that is 1.35 dead load and 1.5 live load. So you can decide to rename it while you are creating your load combination. You can just rename it for you to understand it, but this is over time I've been getting it. Now we have the component. We have F11, that is the force in 1 direction. This is 1 is the x direction. Then we have F2, that is this direction. Then we have F12, which is the corner like an angle, F12. We have F max, F min, FVN, V1. This is shear forces, and this is moment. So moments in the 1 direction, moments in the 2 direction, and moments in the torsional direction. So we have M max and M1. We also have the contour and all this. So for example, now I want to check the M11. So I click OK, click OK. So this is the moment in the M11 with Udicon 2. So you can see this blue line now means the value of 25. So once I put it now, so I can have a value of 7 kilonewton meter. That is the moment I'm having there. Then at this point, I'm having hugging moments. Okay, so you can see the hugging moments around here. And we remember the code says that for the hugging moments it should be about 25% of this span and this span, but the finite element has already given us the exact area, so we don't have to put 25% on it theoretically. But it doesn't make sense to get to site and say, okay, stop here and put your reinforcement, stop here, put the reinforcement and stop here. So what we just do is we just agree with the code and say we use the reinforcement here for it. So this is M11. Most of the reinforcement is going this way. This is M11. So we've seen our reinforcement here. So we need a moment of 14 of it. That's 14 kilonewton meter. And you can also see here, because this place is stiffer, don't forget that load goes to more of the stiffer direction. Since this place is stiffer, you will need more reinforcement at this point. So let's check our M12. So come back here and check M22, apply, click OK. So in this direction, so you can see most of it in this direction, in this direction, in this direction. Okay, so let's check our M12, select it and check M12, click OK. Now M12 is at the torsional reinforcement at the corners. So manually, if you are designing, all you need is to use your wood and hammer equation, and the wood and hammer equation is combining the M11 plus the M12 and the M22 plus the M12 to get your moments. That's the best way to use the wood and hammer equation. Okay, so we've gotten this already. So one method you can do is to use the wood and hammer equation to design it manually. Just get your torsional moment and your moments in either the M1 and the M2 direction and design it. Okay, so after doing that, now let's go straight to slab design. Okay, so we can highlight the whole structure, go to the whole structure, come to this place, concrete slab design, or come to design and choose slab design, concrete slab design. So we have view revise preference. So country, I'm going to choose United Kingdom, so I can infill all these other parameter. So minimum cover for slab, the code says minimum 15. I'll choose minimum 15. Preferred bar size, I want to use 12 mm. So inner slab rebar, that is the one on top, it can be layer B or layer A. Now layer A is in the X direction, layer B is in the Y direction, so I'll choose layer B and leave it that way. So this is for pre-stressed, which is going to be designing the advanced course of ETABS, so you can also subscribe for that. So minimum type of slab reinforcement, do you want to design it in 2-way or 1-way? So I always advise us to leave it as 2-way, because even a 1-way slab will also be designed because of the distribution bar. So I'll clip it as this. Then this is for pre-stress, we'll be leaving this. Okay, so I click OK. The next thing I need to do again is check for flexural design. Now we have view, design and override. We have the strip based and the finite element based. The reason why the strip base is grayed out is because we've not drawn any strip we want. So for the first video, that's in this video, we are going to be using the finite element base to be doing this. So I'll select the finite element base and I'll choose my rebar material and I'll select grade 460 and I can choose whichever cover I want, but the cover I've set it to from preference, so I don't need to change it at this point. So I click OK. So after that, the next thing you need to do is select design combination. So for my slab, I only want to use Udicon 2 for my combination and I click OK. I don't want to use the wind load. I'm not interested in that for now. So I've done that. Then the next thing I'm going to do is select the story for design. So since I have typical story, I just need only one story for the design. So I'll choose the first floor and click OK. So it's only the first floor I'll be using as my reference point. So click OK and let's say it on the first floor. After that, select it and start design. So it's starting the design with the finite elements. So okay, so we can see this is the design of the finite element now. So let's teach us how to interpret it, and that's going to be in the next video. So if you have any question concerning the slab, you can always drop it in the comment section.